Hello and good day. I'm Karl Harvey Guzman, and this will be my final project for ITIM05, which is the data analysis. So let's open. I'm going to do the iris dataset analysis, which is a classification. So this is the dataset information. As you can see, it says here that the dataset contains three classes of 50 instances each, where each class refers to a type of iris plant. One class is linearly separable from the other two. The latter are not linearly separable from each other. So in this data analysis, we are going to identify what type of iris plant by looking at these four attributes. The first attribute, the sepal length in centimeter, and then the second, the sepal width in centimeter, and the petal length in centimeter, and the petal width in centimeter. So the fifth attribute are the classes, which is the iris setosa plant, the iris versicolor plant, and the iris virginica plant. So first, let's input some modules. So we're going to import pandas as PD, and then import numpy as np, and we're going to import OS so we can handle some files if it's necessary. Then import matplotlib, that pyplot as DLT, so we can do graph. Then we're gonna import Seaborn as SNS, and then let's import warnings. So if there are any warnings that we're going to be phasing ahead, warnings that filter warnings, then ignore. So let's run. So for the second part, we're going to load the data set that we have. So we're going to use the pandas pd.read underscore csv for the CSV file, and then the file name of our CSV file, which is the dataset.csv. And then I'm going to use the head method, so I can see the first five of our dataset. So I can actually see the columns that I have. I'm gonna run it, and as you can see, these are the contents of the datasets. So you can see we have the ID. This is the sepal length in centimeter, the sepal width in centimeter, the petal length in centimeter, and the petal width in centimeter. And these are the species. So we don't actually need the ID number. So let's just drop the unnecessary columns. So I'm going to type df equals df.drop columns equals to the ID column, and then let's view again the changes. So as you can see, it's been removed from our columns. So the next thing is we're going to describe the data type. So we're going to show so the next thing that we're going to do is we're going to describe our data set. So let us type describe and then semicolon, and then close and open parentheses, and then let's run. So there, this is the maximum, the minimum, and the percentage of it being the same, and the percentage of the contents, and the count. So the next thing is that we're going to view the information of our data set, the data types that has been used, and then the memory usage, and also the number of columns. So I'm going to type df.info, then close open parenthesis. That's one. So as you can see, is the range 150 entries, and then the data columns we have total of 5, and the data types that has been used is the float and object, and the memory usage is 6 kilobyte. So next, we're going to display the number of samples on each classes. So I'm going to type df and then species, the column name, and then value underscore counts, close and open parenthesis, and then we're gonna run it. So we have 50 iris versicolor, we have iris setosa, also 50, and 50 iris virginica. So these are the name of the column. So this is the name of the column, and this is the data type. Let's go to the pre-processing of the dataset. First, we're going to check for all the null values. If we have any null values, so we're gonna type df is null, we'll close and open parenthesis, and sum, close open parenthesis. Then we're gonna run it. So actually we have no null value, which is a good thing. Now let's go ahead to the exploratory part of the data analysis. We're going to output the histogram of our dataset. So we're gonna type df sepal length in centimeter, and then histogram, close open parenthesis, and then let's run it. Oh, I forgot the letter N. Let's run it again. So what we're looking at right now is the histogram of the column sepal length, and we're going to do that for the rest of the columns. So here in the y-axis we have the counts, and in the x-axis we have the values of the sepal length. So 4.5, 5, 5.5, 6, 6.5, and etc, etc. So over here we have 9, 4.5, and then 22, 20, 23 of the 5, I guess 23, and then 27 of the 5.5, and etc. So we're going to do that to the rest of the columns. So let's view again our columns. So length, width, petal length, and then petal width. So let's copy this code, and then let's paste it. So we're gonna type width and then run. So these are the values of width and the quantity or the counts. So let's paste it here. We're gonna type petal. So for the petal length, so we have here the graph of for the petal length, and then we're gonna copy this, and then we're gonna type here petal. Okay, so the histogram or the graph for the petal width. Now let's go ahead to scatter plot. So what I'm going to do is I'm going to plot the plot points on each class, and also set a specific color for each class. So let's do colors is equal to, let's type here red, and then let's make the second one yellow, and the third one let's set it to blue, and then of course the species equal to, so the different classes that we have, the iris, virginica, and then the iris versicolor, and lastly the iris setosa. Now after we've defined the color for each classes, let's run, and then I'm going to iterate each classes. So I'm going to type for I in range. So we have 3 classes, right? And then we're going to filter row, df for species, and then is equal to species. And then die there, and then plt dot scatter plot, plt dot scatter, and then close parenthesis, open parenthesis, then type x for sepal length in centimeter, and then x for sepal width in centimeter, then comma here, c is equals to colors I, and then for the label equals to species of I. Okay, let's run it. So as you can see, we have a lot of D points for each class, but I can't deny that there are still some missing data. So for that, I'm going to type plt dot next label. So we have labels for the x-axis. Let's name it petal length, and then okay, here we name it petal width for the y label, and then let's set it as the legend, plt dot legend. So let's run it again, see if we have here some changes. So now we have the labels for each of the 3 classes, and also title here for the x-axis and a title for the y-axis. So for that, I'm going to type plt x label for sepal length, and then I'm going to copy this for the y label, width, and then let's bring it y label, and then let's set it as the legend for this graph, and then let's run it again to see if there are some changes. So now we have the legend for iris virginica, iris versicolor, and iris setosa. And here we have the title for sepal length and the sample width. Now let's do that again for the petals. So let's copy this and let's paste it here. So we're just gonna change some things, like here we're going to put petal for the petal length. Then let's put here petal width, and then so we can plot the points for the petal x x label petal, and then for the y label petal width. Okay, so let's run it again. And okay, so this is the plotted points for the petal length and petal width. We have the legend also for Iris virginica, versicolor, and setosa. So the y-axis, the petal width, and the x-axis, the petal length. So we have here again. So just by looking at the graph, you can already see the differences of each class. So petal width and petal length for Iris setosa is pretty short. And then for the versicolor, it's kind of the average. And the virginica has a pretty long length and width. So the next thing that we're going to do is plot both sepal length and petal length. So let's put here petal and then length. And then let's put here petal length for the y level, and let's run it again. Oh, I forgot the letter N. Okay, so you can see here again the differences of each class. And then the next combination, you guess it, we're going to do both width. And then here we're gonna type petal width. So here, type width. And then petal. So let's run again. Okay, so you can see the differences here too of the classes. Right now we can actually see that virginica is the longer and wider, and setosa is the shortest. And so after all the techniques that we used, I can say that this one is the best because you can separate each class easily, because you can see clearly the differences for each class. So next is the correlation matrix. The correlation matrix is a table showing correlation coefficients between variables. Each cell in the table shows the correlation between two variables. The value is in the range of -1 to 1. If two variables have high correlation, we can neglect one variable from those two. So we're going to construct a correlation matrix from the input attributes, variables. So if the value is in between 0 and 0.1, it means there's not much correlation between those. Okay, so let's create the correlation matrix. Correlation, and close parenthesis, and then run. Okay, so we can see 1 and -0. Not much. Okay, so now what we're going to do is we're going to type correlation is equals to df dot correlation, no parentheses, then figure ax is equals to pot dot subplots, and then we're gonna set the figure size to 5 by 4. And then we're gonna use the Seaborn SNS. We're gonna use the heat map for the correlation. Not mutation is equals to true. Let's put some annotation there. AX is equals to AX, and then CMAP is equals to cool and warm. So let's run it. Okay, we have the heat map for our dataset. It's very efficient to see the correlation matrix in the form of heat map. You can also change the size if it's pretty small. Let's change it to 10 by 10. So now we can see much clearly the heat map. So it's ranging from cool to warm. So based on the colors, we can figure out which values have higher correlation and less correlation. Okay, so let's bring it back to the usual size. Okay, so as you can see, sepal length has a high correlation in here, and then also petal length, petal width, and these values, the 0.82, negative 0.36, so we can neglect those values. So by the color that we use, you can easily spot the intensity of or the higher correlation that we have. So this red colors, meaning they have higher color correlations. The cold color ones are the negative or less correlation, and the light colors means not much correlation or just a small correlation. Now that's all for correlation matrix. Apparently we only have 4 values, so we're not going to neglect any of those. Now let's go to the label encoder. So in machine learning, we usually deal with datasets which contains multiple labels in one or more than one columns. These labels can be in the form of words or numbers. Label encoding refers to converting the labels into numeric form so as to convert it into the machine-readable form. So before, we had 3 classes, right? So Virginica, versicolor, and then the Setosa. We're gonna make those label and turn it into numbers. So the first species will turn into the number 0, and then the second will turn into number 1, and then the third label of the species will turn into number 2. So let's type here from sklearn that pre-processing import label encoder, and then let's put LE for label encoder, encoder, and close open parenthesis, and let's run. So now it has been imported. We're gonna do df for species, and then label encoder fit transform, then df for species, and then let's run it, and let's see how it turned out. Let's view our dataset. Let's view our dataset. And let's run it. So now you can see the first label, which is the versicolor, Virginica, has turned into the number 0. So let's check the tail. Okay. So see, the third label has turned into the number 2, which is, I think, the Setosa. But for us to be sure, let's go ahead and check in here before. Okay, so the first label is actually Setosa. So let's check which is the last label by typing it in here. or just let's do it in here. Okay. So the last label is actually the Iris virginica that has turned into the number 2. So which means the number 1 is the Iris versicolor. Okay, now that has been said, let's go to model training. So before training the data, we need to train and test the data to validate. So for that, let's type here from sklearn that model selection. Let's import train test split. So we need to split the data to train and testing. So this is the percentage for training and testing of the data. So let's put here x equals to df.drop columns for species. And then y equals to df for species. And then x train x test y train and then y test then is equals to train test split x y and then test size is equals to 0 and 30. So let's run it, and we run into an error 0.30. And let's run it. So let's input some classification models. So first, let's do the logistic regression. So let's type from sklearn linear model import logistic regression model equals logistic regression and then open close parenthesis. So let's run. And then after we have defined the model, let's train the data. So to train the data, we type model dot fit x train and then y train. And then let's run. So you can see logistic regression. This is the input attribute and this is the output attribute. So after that, now I have to print a metric to get the performance of the model. So to do that, I'm going to type print and accuracy. Now let's do that. Then comma here, model score of the x test and the y test. And then let's set the percentage to 100 and let's run it. So as you can see, we have 97.7 accuracy. So meaning we have achieved a high accuracy for the logistic regression. So now let's input other models. So here we're gonna input the k nearest neighbor. So to do that, I'm going to type from sklearn dot neighbors. Let's import the kn the k neighbor classifier, and then the model is equals to k neighbor classifier, and open close parenthesis, and then we're gonna run it. So to train the label, we're gonna type model.fit just like before, x train, and then y train, and run it. K neighbors classifier. So again, we're going to print a metric of the model to get the performance. So print, we can just copy this, just like before. Yeah, gonna see the accuracy of the model. So again, we have achieved 97.7% accuracy for the K-neighbors classifier. And now, let's try to input some high-level models. So I'm going to use that decision tree. So from sklearn dot tree, let's import the decision tree classifier. Decision tree classifier. So again, the model decision tree classifier. Now, let's run. So in order to train the data again, we're gonna type model.fit x train, and then y train. So let's run let's print the metric model to get the performance. So let's copy this, and then let's paste it in here. Let's see how accurate we got. So again, we have achieved 97.7%. Now with that being said, we can achieve a higher accuracy for the model training if we try doing it several times. But for now, that's it for the data analysis of the IRIS dataset simple model, and that's it for my final project. Thank you and have a great day.